Hi there, in this video we are learning how to find out the probability by using the tree diagrams. So to begin with, the few things about the probability that we know that the sum of the probabilities should always be add up to 1. The next thing that we should know about the probabilities is there are so many ways of expressing the probability. It could be written in terms of a fraction, decimal or the percentage. Den and Becky, and what is about is Den and Becky runs a race and play a tennis match. So the two things they're doing is one is a race, another is a tennis match. The probability that Den wins the race is 0.6. The probability that Becky wins the tennis is 0.7. First of all, I'm going to write down both the games here. So the first information is about the race. The next one is about the tennis. Okay. Now, because they're talking about the win and win, so when they talk about the Den, they talk about the Den's win. When they talk about the Becky, they talk about the Becky win as well. So it means in both the cases, they're only considering the win and win. Okay, but it's obvious that if one is winning the race or the tennis game, the other would be losing it. Okay, the first part of the information is to complete the tree diagram. So we're going to start with the first one. So what happens if the Den, what is the probability that the Den will win the race would be 0.6. So I'm going to write it down. For the Den, I'm taking the initial D and W is for the win. This is for when the Becky win. I'm going to fill that in here as well. This is for the Den win. This is for the Becky win. Now this is again the when Den wins and then Becky win. Okay, so I've got the initials and I have written down with respect to the win because the whole thing is about the winning the games. Okay, what is the probability that the Den will win the race is 0.6. So this is 0.6 here. Because we know that the two branches should be add up to 1. So if the probability for the Den to win the race is 0.6, then probability for Becky to win the race would be the remaining of it. So you can do 1 minus 0.6 and that would gives you 0.4. So you would have 0.4 over here then. Now we're going to go to the next piece of the information where it says that the probability that Becky win the tennis is 0.7. So the probability that Becky win the tennis is 0.7 and here Becky is winning again, so it would be 0.7. Because we know that the branches should be add up to 1, so you do 1 minus 0.7 and that would gives you 0.3. So it means for the Den to win the tennis game, the probability would be 0.3 and 0.3. Here we have got the question given in a decimal, so we are writing down all the information in the decimals and we would have to have the final answer to be written in the decimal form as well. Okay, I'm going to read the first part. The first part is done already where we have to fill in the tree diagram, which we have done. Now the B is use the tree diagram to calculate the probability that Becky wins both events. So it means that we are finding out the probability when Becky win the first one, Becky win, and then again the second one, Becky win as well. So Becky will be winning the race as well as winning the tennis game. We're going to have a look. So for the first one to Becky win the race, the probability is 0.4. And for the Becky to win the other, which is a tennis game, is 0.7. So we are considering a combination where Becky is winning both the games. So we're going to write down the probability of when Becky winning the race would be 0.4. Then Becky winning the tennis game would be 0.7. And we know that because 4 times 7 is a 28, so you'll get 0.28 here. So the probability of Becky winning both the games is 0.28. This is BI. There's a II as well. So the probability that the race and the game are won by different people. So it means not the one time maybe Becky's winning, another time Den would be winning. So we're going to first write down the combination for the II. So one of them would be winning means probability. So if you look for the first one that Den is winning and Den is winning, we're not going to take this one because we are choosing the ones which we are winning the two different people. So the first combination would be Den win and Becky win the next one. So in other words, Den would be winning the race. Becky would be winning the tennis game. Okay. Now we're going to look to the next combination now where Becky winning the race and the Den would be winning the tennis game. So the next combination, we always write down the next combination having the plus sign in between. So the probability of Becky win and then the Den win. So this is Becky winning the race this time and Den would be winning the tennis game this time. Because it says that it needs to be won by the different people, that's why we have taken the combination where they are winning the different people. Now, let's think about it that the last combination so we are having is a Becky win and Becky win. We're not going to take this one because we are looking for the different people to win the game. We're going to write down in terms of the probabilities now. So, Den to win the race is 0.6 times Becky to win the tennis game is 0.7. To do the next one now, Becky to win the race would be 0.4 and Den to win the tennis game would be 0.3. You're going to multiply them together. So 6 times 7 is a 42. You'll get 0.42. The next is 0.4 times 0.3 would be 0.12. When you add them together, so you'll get 0.54. So here's the probability when two different people wanted different games. Alright, so here we have got the next example now. We're going to just read it, gather the main information. What we see that here is now the probabilities are given in the fraction form. So here this is that Sally plays one game of the tennis and one of the snooker. So there are the two different types of the game. One is a tennis, another is a snooker. The probability that the Sally wins at snooker is 2/3. The probability that she wins the tennis is a quarter. So here's the probability given for Sally to win the snooker game and the tennis game. Now, the first thing is you're going to write down the games here. So the first game is a tennis. So I'm going to write it down here. The next game is a snooker, which is here. Now, for her to win is this probability. Not win, I'm taking as a W dash. Again, this is a win. This is not win. This is a win and this is not win. What is the probability for the Sally to win the tennis game would be is 1/4. So this is going to be winning is 1/4 because we know that the branches should be add up to 1. And to find out if the probability for the Sally to win the tennis game is quarter, what's the probability for losing would be 3/4. You can do even by doing 1 minus 1/4. So that would be 3/4, the remaining fraction. Now, for Sally, to win the snooker game is 2/3. So that would be 2/3 here. That's the win of the snooker game. So if 2/3 is the probability for her to win the snooker game, what's the probability of not winning her the snooker game would be 1/3, the remaining fraction, and the remaining fraction would go here as well. Now, we're going to see that this is the first part done, where this says that complete the tree diagram. Let's have a look to the next one now, which is the part B. In the part B, this says that work out the probability that Simon win both games. In other words, if the Simon is winning both the games, it means Sally would be losing both the games. So probability, there's another person named Simon. So I'm going to write it down. Simon wins both games. So it means that, in other words, we say that what is the chances or what is the combination when Sally is losing both the games. So here's going to be the lose for Sally and this is going to be the lose for Sally. It means that if Sally is losing the game, the other person, Simon, would be winning the game. How we're going to write down the probabilities would be 3/4 times by 1/3. Simplifying the fraction, you multiply the top number with the top number and the denominator with the denominator. Because they both goes in a 3 times table, that would be 1/4. So the probability for the Simon to win both the games is 1/4. Let's read the next one now, which is B is done. Now we are going on to the C now. So work out the probability that Simon win only one game. So probability that Simon win only one game. Okay, so I'm going to just now try to understand because this is the whole tree diagram is given to us with respect to Sally. And this says that to find out the probability when Simon win one game. It means that when Sally will lose one game, it means, in other words, Simon would be winning that game. So we can take the combination where there's a win and there's a lose, or where there's a lose and a win. I'm going to write it down now. Probability of the win and the lose. Then the next one would be lose and the win. So I say that W dash is representing the lose then, and there would be a win here. So in other words, how we're going to read it, because Simon has to win one game, so when Sally is losing the games, it means Simon is winning those games. Okay, we're going to write it down now. So win is 1/4 times not win is 1/3. So this is the first combination we have chosen, which is this, with the win and the not win. The other one is we have chosen the not win with the win. So not win with the win would be this combination. So the fraction of this would be 3/4 times by 2/3. You're going to simplify them together. So it would be 1 over 12 plus 3 times 2 is 6, 6 over 12. And the final simplification would be 7 over 12. So the probability for the Simon to win only one game would be 7 over 12. We have got the next example now. So with the next example, it says that the probability of Rebecca will win any game of the snooker is the P. So now it's not given us in terms of a number. It's not in a fraction, decimal, any form, but it's just with the letter P. Now she plays 2 games of snooker. Okay, so complete in terms of P, the probability tree diagram. So we're going to see that because we know that the branches should be add up to 1. So if this is P, then the other one would be 1 minus P. I'm going to fill in, if the win is a P, then lose would be 1 minus P. Win is a P, so lose would be 1 minus P. We have got our tree diagram to be filled in terms of P. Now to do for the part B now, it says that write down an expression in terms of P for the probability that Rebecca will win both the games. So it means that we are looking for win and win. So the probability of win and then win is this combination basically. So we're going to multiply them together. So that would be P times P would be P squared then. Because this says that you're leaving the answer in terms of P, so we're going to leave it like this because we don't have the numbers given and we can't do more simplification on it. Let's read the part C now. So with the part C, write down an expression in terms of P for the probability that Rebecca will win exactly one game. Now we are looking for the case when she's be winning exactly one game. It means that winning the one game means it would be win and lose combination. The other one would be lose and win combination. So these are the combinations we are looking for. I'm going to write it down, but before I'm going to write down, I'm going to just tidy up everything. So there's not going to be too much stuff on it. We are looking for the probability exactly one of the games. To find out the probability for exactly one of the game, it would be win and lose. So probability of win and lose is the first combination. The next combination is the lose and the win. So I'm going to write down probability of lose and the win. Okay, I'm going to write down now them together. So whatever the combinations we write down between them is always the multiplication sign. So P times by 1 minus P plus, what's the probability of the lose is 1 minus P times by P. How you're going to simplify it further now, you're going to open up the brackets and then do collecting like terms. So you do P times 1 is the P minus P square plus P minus P square here as well. Now you're going to do collecting like terms. We have got P and plus P would be added together to make a 2P. Minus P square and minus P square, I can circle them. So that would make minus 2P square. Or you can factorize 2P from here. That would give you this thing, which is 2P1 minus P. So if you leave your answer like this or this, they both are the fine forms because this says that you have to write it down in the expression form in terms of P. Here we have got the last example on this. So let's read and highlight the key information. It says that Julie has 100 music CDs. So the total number of the CDs is 100. 58 of the CDs are classical, 22 of them are the folk and 30 and the rest of them are the jazz. On Saturday, Julie chooses the CDs at random from 100 CDs. On Sundays, she again chooses from the 100 CDs. Now we're going to complete the tree diagram and we see that the probabilities written in the complete diagram, in the tree diagram is written in the decimal form. So now we're going to complete it first of all. So we have got 0.58, we have got 0.22. We know that the decimal number should be add up to 1 because all the branches should be add up to 1. That's how the probability works. So to find out how many are the jars, so you do 1 minus 0.58 and you minus 0.22 from it. So you get the probability of the jazz CDs would be 0.20 from here, which I'm going to write it down over here. I'm going to write down the classical is 0.58. So where there is a classical, I'm going to write down 0.58 here, then 0.58 here, and 0.58 would be here as well. I'm going to write down the next one now. So where there is a folk, it would be 0.22. So I'm writing it down 0.22 here, then 0.22 would be here, and 0.22 would be here as well. The last is the jazz CD. So the jazz is 0.20. You can write it down. 0.20 would be here. Then we are having 0.20 would be here, and 0.20 would be here as well. So we have got the tree diagram completed now. To do the next one, calculate the probability that Julie will choose a jazz CD on both Saturday and Sunday. So it means we are finding out the probability of the jazz to be having on Saturday and Sunday. So let's circle it. So this is on Saturday and this is on Sunday. So what we're going to do with both the probabilities is simply we're going to multiply them together. So it would be 0.20 times by 0.20. And when you multiply them together, you get 0.04. So this is the probability for Julie to having the jazz CD on Saturday and Sunday both, which would be 0.04. Now, we are done with the part B. Now, C is calculate the probability that Julie will choose at least one jazz CD on Saturday and Sunday. Okay, now we would have a lot of combinations here because there's a word at least. So, at least means it could be one jazz CD or it could be both of them other jazz CDs. We're going to read the information now. So, we're going to start with here. So, classical and jazz would be the first combination we can make. Okay, I'm going to start with the first one now. So as I said that the classical and jazz could be the first combination. So I'll use the initials. So C and J is the first combination. Then I can just go because at least one of the jazz means it could be folk and the jazz. So it could be F and J is possibly the next combination. We're going to add all the combinations together. The next would be jazz with a classical. So would be jazz and classical. The other one would be J and F. So probability of J and F. And the last one would be probability of J and J. Because we say that at least means it could be both of them would be jazz as well. Now you're going to write down all the probabilities and you're going to multiply them together. So we have got all the combinations written here. But because we don't have enough space, the remaining information, I'm going to write it down on the other side. So I'll be rewriting it now. So the combination we get from previous would be probability of C and J, which is classical and jazz. Then probability of FJ. Then we are looking another combination would be probability of J and C. Then probability of J and F. And the last is probability of J and J. Now the probability of the classical is, we know that is 0.58 times jazz. So jazz is 0.20. So probability of F is, we know from the previous, which is 0.22, and the jazz is 0.20. That's the next combination. The third one is a jazz and a classical, which is this one. So the jazz is basically 0.20 and the classical is 0.58. The other one we'll be doing is the probability with the jazz and F. So it would be jazz we know is 0.20 and F is 0.22. And the last we're going to write it down with again adding them together with the jazz and jazz. So that would be 0.20 times 0.20. When you simplify all of them together, you'll come out with the answer which is 0.36 then. So this is the probability of at least having one jazz CD either on Saturday or Sunday. At least means we remember that we also consider the combination where we are taking both the jazz CDs as well. And whatever the combinations, remember there's always the positive sign in between them. Here you go. You add all the combinations together and you're going to get the final answer would be 0.36. So here is the whole explanation, like really detailed explanation on how to attempt the questions on the probability using the tree diagrams. And I hope you have found this video helpful. So please subscribe to my channel so you'll be able to just like catch up with more videos on more topics. Thank you very much.